Bismillahirrahmanirrahim. Assalamu alaikum. I'm Anamtabul Gayoom, roll number EBP 2101020, and I'm going to present section F, that is latest techniques to perform acid hydrolysis of polysaccharides. And this new technique is acid hydrolysis of polysaccharides on sulfonated solid acid catalyst. The research and experiment was carried out by three Japanese scientists, Yuki Sakamoto, Kazuya Imamura, and Ayumu Onda from Kochi University, Japan, and their research article was published in American Chemical Society publications. The conventional methods of acid hydrolysis involve the use of mineral acids and enzymes. Their cons are difficulties of product separation, reactor corrosion, and further degradation of monosaccharide. Enzymes are costly, substrate specific, and show slow reactions, so solids with strong, weak acidic sites are being researched and sulfonated carbon catalysts are drawn to attention. Their catalytic active site is a sulfonic acid functional group. Sulfonated carbon materials have higher catalytic activity for hydrolysis per catalyst weight. In this slide, we have two catalysts, sulfonated activated carbon catalyst and amberless 70 catalyst, and the reaction of hydrolysis is shown in this equation where polysaccharide is being hydrolyzed by passing through the solid acid catalyst. In this slide, we have materials for our experiment, which are activated carbon AC, amberless 70, concentrated sulfuric acid 95% concentrated, tetramethyl ammonium bromide, sodium azide, sodium nitrate, HCl, NaOH, NaCl 1 molar, and D-glucose, D-maltose, D-maltotriose, and starch, which should be soluble. Now we have procedure. First, we have catalyst synthesis and pretreatment. Sulfonated activated carbon ACSO3H catalyst is prepared by AC powder with concentrated sulfuric acid at 115 degrees Celsius for 16 hours under flowing argon, which should be 40 milliliter per minute. Wash repeatedly with 3 liters of distilled water at 80 degrees Celsius, and obtained powder is pre-treated hydrothermally at 200 degrees Celsius for 3 hours in a Teflon-lined autoclave to prevent elution of SO4 ions during catalytic reactions. Then we wash it again until sulfate ions are no longer detected in the wash water and it is dried at 100 degrees Celsius. Amberless 70 is dried at 100 degrees Celsius for 6 hours under flowing argon, which should be 50 milliliters per minute. Next we have catalyst characterization. ACSO3H and amberless 70 are characterized by titration, CNHS elemental analysis, N2 adsorption, and TG-DTA measurements. Now we have polysaccharide adsorption and saccharide penetration. Polysaccharide adsorption and penetration properties of catalysts were ascertained using HPLC and the phenol sulfuric acid method respectively. Lastly, we have polysaccharide hydrolysis. The catalytic reactions are then conducted in a closed reactor at 120 degrees Celsius. After the reactions, the reaction mixtures were filtered and analyzed by HPLC system, RI detector, a UV-vis detector, and column GPC. Now coming towards calculations and result, total concentration of water-soluble organic compounds in the resultant solution were found using a TOC analyzer. The product yields were calculated as shown below, which are in percentage. We have carbon atoms in products divided by carbon atoms in introduction substrate multiply by 100, and then we would get product yields in percent. In conclusion, this study investigated the relations between the adsorption properties and the catalytic activities of the sulfonated activated carbon catalyst compared with amberless resin catalyst. From the comparison of reaction rates in this study, amberless 70 with large amounts of high sulfonic acid functional groups is suitable for hydrolysis of polysaccharides with DP 3 or less. The sulfonated carbon catalysts are suitable for hydrolysis of saccharides with dp5 or higher. dp is degree of polymerization. In addition, it also showed that the higher the adsorption amount, the higher the catalytic activity. Therefore, to enhance the activity of the sulfonated solid acid catalyst, it is expected that the adsorption capacity and the penetration degree of polysaccharides will be increased, and the proportion of strongly acidic groups without reducing the adsorption capacity will be developed. So that wraps up my section. Thank you so much for listening and following through my presentation.